Is the Large Hadron Collider opening a portal to hell? The scientific method is undoubtedly one of humanity's most significant inventions. We've evolved from simple apes into a species capable of shaping our environment to fit our desires. Through the rigorous process of exploring the natural world, creating experiments, and making observations, we've built cities, crossed oceans, and ventured into the reaches of the universe, both microscopic and cosmic, over thousands of years. Through the power of scientific exploration, we've split the atom, eradicated certain diseases, created global communication systems, and walked on the moon. The problem is that science is always on the edge of human knowledge. Each experiment sheds light on the unknown, and occasionally, the unknown responds when provoked. What's really happening at CERN? Are they tampering with things that should be left alone? Are they trying to create a portal to another dimension? That's exactly what we'll explore in this video, so stay tuned until the end to catch every detail. But before we dive in, make sure to leave a like and subscribe to the channel. While the overall results of scientific research have been positive for our species, experimentation has its downsides and sometimes pushes the world in the wrong direction, with catastrophic consequences. That's why some people were concerned when CERN's Large Hadron Collider was about to be switched on, fearing it could create a black hole and consume the planet. Remember that a Russian physicist had his own Big Bang moment in 1978 because of a particle accelerator. Anatoly Bogorsky, who worked on a particle accelerator that was thought to be shut down, was in the room for maintenance. However, the warning lights failed, giving him no indication that the accelerator was in use. As he examined the machine, Bogorsky leaned toward the beam and was struck by a burst of high-energy protons that exited the left side of his face after passing through the back of his head. A dose of radiation, hundreds of times greater than the level that would have killed a person, passed through his brain. Bogorsky reported seeing a blinding flash of light. Amazingly, Bogorsky survived the incident, but didn't escape unscathed. The left side of his head swelled in the days following the collision, and the area where the beam contacted his skin burned and peeled. He later developed seizures, mental fatigue, hearing loss in his left ear, and facial paralysis. In 2010, when the Large Hadron Collider began smashing subatomic particles, there was a wave of concern that scientists might have inadvertently brought about the end of the world. Worried critics warned that the LHC tests could create a tiny black hole that would eventually swallow the entire planet. These fears were obviously unfounded. We're still here in 2024, and although it sometimes feels like we're in a hellhole, we're still a pre-apocalyptic society, for now at least. Indeed, the LHC ran smoothly at the European Council for Nuclear Research, CERN headquarters, for several years before it was shut down in 2018 for upgrades. During that time, the discovery of the Higgs boson, a fundamental particle nicknamed the God particle, was made possible thanks to some of the largest global scientific collaborations ever undertaken. The Higgs boson, a subatomic particle, is believed to have been crucial to the development of the universe after the Big Bang 13.7 billion years ago. Research conducted at CERN is also critical for future advancements in various fields, from computing to medicine. Now, with a new phase of research set to push the LHC to produce collisions at unprecedented energy levels, apocalyptic fears have resurfaced. This time it's not just black holes causing concern, but also fears of portals to the multiverse, demonic gateways, and doors to hell. That's what we can expect if conspiracy theories are to be believed. What's really happening? 574 feet below the France-Switzerland border. The LHC, the world's largest particle collider, was built by CERN between 1998 and 2008 and is located near Geneva, in a tunnel 17 miles in circumference and up to 574 feet deep. How does it work? High-energy particle beams are accelerated to nearly the speed of light and collide at 4 points. The goal is to provide answers to some fundamental questions related to physics, including subatomic particle interactions, theories of space and time, and Einstein's theory of relativity. Why is this so scary? Some people have unsuccessfully tried to sue CERN in the past for endangering public safety, indicating an underlying concern about the possible negative implications of using cutting-edge technologies. Black holes and so-called strange matter are the two main concerns related to the LHC. The first concern is no surprise. as one of the LHC's goals is to simulate tiny black holes that might hold information about the Big Bang. Without much technical knowledge, you might think this sounds like a terrible idea. The second concern is that the LHC's high-energy experiments might create strangelets, a fictional substance made of strange matter that could infect the matter making up the rest of the planet. That's a lot of ifs, but there's a reason for it. Strange matter is currently just theoretical and has never been observed in space, where high-energy photons are constantly colliding. After 3 years of upgrades and maintenance, the LHC reopened last year. All of this means that the likelihood of the LHC discovering completely new subatomic particles is currently higher than ever. The resulting discoveries are expected to trigger the greatest revolution in physics in a century. Researchers are not only considering the discovery of a new fifth force of nature, they are also looking for signs of dark matter, a non-observable element that makes up most of the universe. ATLAS, a detector 151 feet long and 82 feet high, is one of 4 LHC devices that examine the particles produced. It is currently more powerful than ever. There are 4 such detectors at the LHC, each conducting a distinct experiment. Protons, which make up the atomic nucleus, are accelerated to near-light speeds around a 17-mile ring, colliding precisely at the center of these enormous detectors. Even smaller particles are produced by the collisions and scatter in various directions. According to physicists, the key to unlocking a new perspective on the universe lies in these unknown particles. The greatest shift in physics since Einstein's theories of relativity would result from the discovery of these particles. The upgraded device has a significantly higher chance of producing and detecting these rare particles. There has also been a significant advance in data collection and analysis from the collisions. Data is collected from each of the 4 detectors in the rebuilt LHC at an astonishing rate of 30 million bits per second. Of course, it's too much information for the human mind to process, but a single collision could contain the crucial information proving that one of the new particles researchers are looking for actually exists. The LHC software has been updated and now automatically analyzes all collected data, using the latest artificial intelligence techniques to find and save measurements that may be of interest for scientists to review. The Standard Model is the most prevalent theory in particle physics. Despite its unassuming name, the theory has been incredibly successful in explaining how subatomic particles combine to form the atoms that make up our environment. The natural forces that hold atoms together, like nuclear forces and electromagnetism, are explained by the Standard Model. However, the Standard Model fails to explain how gravity works or the behavior of dark matter and dark energy, 2 of the universe's invisible components. The LHC was designed to find these particles, which could help us understand how the vast majority of the cosmos functions. Dark matter can be distributed across the universe in computer simulations, and LHC researchers hope to actually discover it. Since April of last year, beams have been circulating through the accelerator and have proven stable enough to resume tests at higher energies than before, with a projected run time of nearly 4 years. This has generated widespread anxiety on social media. This panic comes in many forms, aligning with the recent spiritual awakening of the internet, which has seen conspiracy theorists shift from topics like big pharma and secret military activities to Satanism, witchcraft, and the return of Atlantis. It's true that some researchers are considering the possibility of a multiverse in relation to the Higgs boson. This idea will likely advance as more data is collected in the coming years. But some internet theories are even more absurd, like the theory that the latest experiments will create portals to hell. There's also the theory that tampering with the God particle will soon release spirits and demons that may invade your body. Evidently, identical demonic forces were also active in the years 2012 and 2016, which, to be fair, had different apocalyptic impacts. For years, both in reality and fiction, people have harbored concerns about the Large Hadron Collider. Dan Brown's 2000 novel, Angels and Demons, featured a scene at CERN where the Illuminati steal antimatter to blow up the Pope. The notion that our Promethean quest for knowledge and power could unleash unspeakable evils from another realm was recently revived by Netflix's Stranger Things. But, like most if not all of the theories currently circulating online, all of this is fiction. CERN has also issued a reassuring statement. The LHC can reach an energy that no other particle accelerator has achieved before, but nature routinely produces higher energies in cosmic ray collisions. Whatever the LHC does, nature has done many times over the lifespan of the Earth and other astronomical bodies. Fundamentally, if something truly terrible were going to happen, it probably would have already occurred. However, the energy crisis caused by the conflicts in Russia and Ukraine is not only putting pressure on households and businesses in Europe. CERN and other scientific research facilities are also feeling the impact. A city of 230,000 people would consume about 1.3 terawatt-hours of electricity per year, which is roughly what CERN consumes on average. Almost half of that comes from the Large Hadron Collider alone. CERN is taking extra measures to reduce its energy consumption this year, as the French government encourages the country to embrace energy sobriety. This year, CERN will use the LHC 20% less than last year. Well, that's it for today. If you enjoyed this, don't forget to like and subscribe to the channel. Also, share your opinion on the topic. We'd love to hear from you. Thanks for watching, and see you next time.